Let's subset breast cancer samples by expression level of MTBP to test whether tumors with high MTB expression correlates with other variables such as survival. We will use omic data queries which categorize each sample in TCGALand based on mutations, copy number, expression, and more. Click the Data Query button, choose Add Omic Data Query. We are interested in RNA-seq expression, so choose RNA-seq FPKM. Search for MTBP. We can select a number of ways to query the RNA-seq data. In this case, we will categorize the expression values based on the percentage ranking within the group. In this case, samples within the bottom quartile will be labeled as low, samples above the third quartile will be labeled as high, and the ones in between will be labeled as medium. We will choose discretization for each group so that the relative expression levels will be grouped based on our primary grouping, which is tumor type. Click OK. Each sample in TCGALand has now been categorized based on expression of MTBP, grouped by tumor type. You can find your query under Custom Query. If we filter for breast cancer samples, then group by our MTBP FPKM custom query, we can quickly find all breast cancer samples with high MTBP expression. We can also see this directly on the MTBP FPKM expression view. Let's group by sample type. And change our sample color by our custom query. We can see that samples from breast tissue are only expressing high levels of MTBP when they are tumor samples. Now let's look at survival data between samples from breast cancer with high MTBP expression compared to low MTBP expression. Change the grouping to MTBP FPKM status. And let's hide the medium status. Survival of high MTBP expressing samples is significantly worse than low MTBP samples.